Hello students, today we will discuss zeolite or permuted process. Before starting this topic, zeolite process, I have already told you in previous lecture what is the hard water, what is the soft water, hardness of water, and this hardness is two types like temporary hardness and permanent hardness. This zeolite process is used for both. This zeolite process is used for both type of temporary or permanent hardness. We can remove both temporary and permanent hardness by this process, which is known as a zeolite or permuted process. As we know that what is the hard water? Hard water is the what is the hard water and what is the soft water? As we know that hard water is which does not produce lather with soap solution readily but forms a white scum is called hard water, and what is a soft water which forms lather easily on shaking with soap solution is called soft water. And what is the hardness of water? Hardness is defined as a soap consuming capacity of a water sample. Generally, soap consists of sodium salts of long fatty acids such as oleic acid, palmitic acid, stearic acid. The soap consuming capacity of a water largely due to the presence of calcium and magnesium ions as they form insoluble uh, scum of calcium and magnesium soap which do not have any detergent value. Okay, so this is the hardness of water. Students always hear this zeolite process is for softening of water. Okay, remember this is used for softening of water. What are the zeolites? Zeolites are the derived from two Greek words like zine, lithos, which means boiling stone. The chemical structure of sodium zeolite may be represented as as we know that the name of this hydrated sodium aluminum silicate. The formula is sodium Na2O Al2O3 SiO2 YH2, where X may be 2 to 10 and Y is equal to 2 to 6. Zeolite or permuted is hydrated sodium aluminum silicate which are capable of exchanging reversibly its sodium ions for hardness producing calcium and magnesium ions in the water. As we know that the hardness is due to the presence of due to the salts of calcium, salts of magnesium like calcium bicarbonate, magnesium bicarbonate, calcium chloride, magnesium chloride, and magnesium sulfate, we can say magnesium nitrate. These are all causing permanent or temporary hardness. These zeolites are two types. One is the natural zeolite, other one is the synthetic zeolites. Natural zeolites are non-porous green sands. There is one example like natrolite, which is Na2O, Al2O3, 3SiO2 and 2H2O. These natural zeolites are more durable. In case of synthetic zeolites, these are porous and gel-like structure. And the one more important feature is this: the high exchange capacity per unit weight. Okay, the high exchange capacity per unit weight. This is the synthetic zeolites. These zeolites are prepared from solution of sodium silicate and aluminum hydroxide. Sodium silicate and aluminum hydroxide. Sodium zeolites are used in water softening as Na2Z, where Z stands for the insoluble radical framework. Okay, these are also known as base exchangers. These are also known as base exchangers. When there is one diagram, this diagram, the zeolite water softeners are made in both pressure type and gravity type. A zeolite softener consists of a steel tank packed with a thick layer of permuted. The water enters at the top and passes through the bed of the zeolite solution. Okay, again I am repeating. A zeolite softener consists of a steel tank packed with a thick layer of permuted. The water enters at the top and passes through the bed of zeolite. This is the bed, zeolite bed, which is Na2Z. Here is Na2Z. I am writing here. Na2Z. This is the zeolite bed. It operates on the principle involving alternate cycle of softening run and regeneration run. It works both. It works, first of all, it works as a softening run, and after, when it is exhausted, then it will work as a regeneration run. The water is softened by passing it through the zeolite bed, where calcium and magnesium ions are removed from the water by zeolite and simultaneously releasing equivalent amount of sodium ions in exchange. Okay, this is the where I am repeating. Here is the hard water, okay, on the at the top, and which goes from the zeolite bed. Here is the reaction will take place. There are so many reactions will take place, like calcium bicarbonate. Here is the calcium bicarbonate, and this is the zeolite bed. This is, all these are causing hardness: calcium bicarbonate, magnesium bicarbonate, calcium sulfate, calcium chloride, magnesium sulfate, magnesium chloride. All these are causing hardness. This is the hard water. When it is passed through a sodium zeolite, there is one reaction in which calcium is insoluble framework and Z is also insoluble, and both insoluble frameworks are combining. Okay, this is the calcium zeolite, which is insoluble part, and it remains in the equipment, okay, in zeolite equipment. But this is the salt bicarbonate, and this is the sodium, which is soluble. This is also soluble, okay. So these are combining to the form the salt of the sodium bicarbonate. This is the salt of sodium bicarbonate. Okay, so this is the sodium bicarbonate. What is the process? I am repeating. What is the process? In this process, hard water passes through a specified rate through a bed of active granular sodium zeolite present in a sodium zeolite softener. When the calcium magnesium ions are taken up by the zeolite as the zeolite as the calcium zeolite and magnesium zeolite respectively, while the outgoing water contains equivalent amount of sodium salts. So these are the some reaction in which the soluble parts, which is the soft water, okay, it goes out from the equipment outside, but this is the calcium zeolite, which is insoluble part, which remains in the equipment. These are like these reactions are also here. Next, regeneration. After some time, when the zeolite is completely changed into calcium and magnesium zeolites, then it gets exhausted and it ceases to soften water. It can be regenerated and reused by treating it up with a 10% brine solution. This is the calcium zeolite, which was the insoluble part. It reacts with the sodium chloride solution, which is brine solution, which is 10% brine solution, and the formation of again sodium zeolite, which can be further used for the softening of water. And this is the hardness producing, like calcium chloride. And this is the another reaction: magnesium zeolite react with the sodium chloride, forms the sodium zeolites and MgCl2. What will happen after some time? Zeolite is completely changes into calcium and magnesium zeolite. Then it gets exhausted. Okay, when it gets exhausted, we can regenerate it. This is the regeneration process. What are the merits of zeolite process? It removes the hardness almost completely. And always remember, zeolite process is used for both the hardness, like temporary hardness and permanent hardness. The process automatically adjusts itself for variation in the hardness of incoming water. This process does not involve any type of precipitation, no problem slush formation. There is no slush formation, and this equipment is very very compact. Okay, this is very important point. This equipment is very compact and occupying a very small space. Okay, occupying a very small space. So I can write here, this is one another. These are the demerits of zeolite process. What are the demerits of zeolite process? The outgoing water contains more sodium salt. This method only replaces calcium and magnesium ions by the sodium ions. And high turbidity water cannot be softened efficiently by this zeolite process. Okay, these are the demerits of the zeolite process. And next one is the limitations of zeolite. What are the limitations of zeolite? Water must be free from turbidity and suspended matter. Hard water should not be used as zeolite tend to dissolve in it. Water containing excess of acidity or alkalinity should not be used as mineral acid may destroy the zeolite bed. Okay, so always remember, this zeolite process is used for the softening of water. We can convert hard water into soft water. What we are using sodium zeolites, and the formula of zeolites are hydrated sodium aluminum silicates. So this is the very important topic for your semester and sessional exams. Okay students,